Hi, everybody. Welcome back. We have to continue with these functional groups, where again, remember the base is that these are hydrocarbons, and we've replaced or added something to the hydrocarbon. So the next set are ethers, and if you look in table R right here, ethers have an oxygen in the middle of a carbon chain. Okay, so you see that R group, that would be a carbon group, and this R group would be another carbon group. Okay, so I like to just write, just so that you understand, the oxygen, not two oxygens, only one oxygen, and one oxygen in the middle of a carbon chain. Okay, and then obviously these carbons could be connected to more carbons, or they could just be connected to hydrogens. Okay, so you can see here, that's your ether functional group, and you have to know how to name these, okay? So when you name these, you look to the right at how many carbons there are. There's 2 carbons in a row, and if you remember 2-carbon chain, we called ethyl, right? Oops, sorry, I lost where my... And if you look to the left, here, there's another ethyl group. Again, remember, rather than saying ethyl, ethyl, we say diethyl. And then it always ends in ether. I lost my guy here. There he is. Diethyl ether. Okay. So again, we have our oxygen in the carbon chain. We look to the, you go to the side with the lower number of carbons first. So if they're not equal, so we look here to the left, and that's a 1-carbon chain, so that's methyl. And then you look to the right, and that's a 2-carbon chain, so that's ethyl. So this is methyl ethyl ether when we name them. Don't sweat the naming. Usually what I do because I forget all these rules from year to year, is I just look at the example in the reference tables that they give, right? Which is exactly the one that we just did. Here's your oxygen in the middle. You look to the left, there's 1 carbon methyl. You look to the right, there's 2 carbons ethyl, and it always ends in ether, okay? All right, now I have a riddle for you. What do you call this? You guessed it, it's the ether bunny. I know you miss my sense of humor. All right, organic acids are the COO group. We've already talked about these. They're weak acids, right? They have the COOH group. And what the COOH group looks like is a C double bonded to O, and then that C is also bonded to O, that's bonded to an H. And then that is either attached to a hydrogen or a carbon chain, but that's your COO group there, okay? We name these like they're an alkane, okay? So you would name these like an alkane, but you drop the E and add, oh, I see acid, okay? See, oh, I see acid. So if we take a look at this first one, there's 2 carbons. So if it were an alkane, we would name it ethane, but we drop the E and add, oh, I see acid. Ethanoic acid. And ethanoic acid is acetic acid, which is the active ingredient. Remember, we titrated it. It's about 0.83 molar ethanoic acid in vinegar. Okay, if you look over here, we have 1, 2, 3, 4 carbons. So that would be, if we named it like an alkane, name it like an alkane, butane, and then, oh, I see acid. So organic acids have 2 oxygens, and they have this COO group, always at the end. It will always be at the end. It can't ever be at the middle, okay? Those are organic acids. They're weak acids. Esters. Esters are what you're smelling when you go outside right now. Any beautiful smelling, they have strong, fragrant aromas. So flowers and perfumes and, you know, the strong smell of fruits, Those are all due to the presence of esters. And esters are a COO group. So it's like an organic acid. It has the C double bonded to O, but this O is then bonded to a carbon. Let me erase that rather than put R. Let's bond that to a carbon. And then this carbon can either be bonded to an H or it can be bonded to more carbons, okay? So they have the two O's also, but notice the difference. In an organic acid, this O is bonded to H. Here, this O is bonded to another C. These are the hardest ones to name. So let's look at what they've done and see if we can't figure it out for some compounds. Here's our beautiful smelling ester. Okay, see how she has two O's, okay, right here. So you go to the O that's in the chain, not the double bonded O. You go to the O that's in the chain, kind of like an ether, and you name what's away from the double bonded to O. So in this case, it's to the right, but if I drew it the other way, it would be to the left. So this is methyl, right? So you go away from the other oxygen. Name that, one carbon chain, methyl. Then you start at the double bonded to O and count the carbons, 1, 2, 3. We would call that propane. It's a 3-carbon chain. But because it's an ester, we drop the E and add O8. So methylpropanoate, okay? Let's look at a couple of these and see how we can figure it out. So we go to the oxygen, that's not the double bonded to oxygen, and we name that chain. That's a 2-carbon chain, so that's ethyl. Then we find the C that's double bonded to the oxygen. We start there, count these carbons. There's 3. That would be propane. But we drop the final E and add O8. Okay, ethyl propanoate. Okay, let's just do one more just so you have the hang of it. Here's our O that's not the C double bonded to O, right? Okay, so we count the carbons attached to it. 1, 2, 3, that's propyl. And then here's the C double bonded to O. We count the carbons there. There's only 1. So we would call that methane, but we drop the E and add O8, okay? And again, here, the O that's not double bonded first, methyl, then the O that's double bonded. 1, 2, 3, 4, methylbutanoate. All right, we have, I think, 2 more, maybe 3 more. We have amines, amino acids, and amides left, and they all kind of sound the same, so it gets a little bit confusing. So if you go here and look up what an amine is, right? An amine is an NH group that's attached to some carbons, okay? So like ammonia, right? These are all derived from ammonia. So it's like you have ammonia, which is NH3, but then you attach it to the carbon chain. So it's just an N group. Now these N's can have more than one carbon attached, or these could be hydrogens, okay? Like that. Or you could have, you know, something like this. But either way, there's an NH group attached to the chain. So they're formed when one or more of the hydrogen atoms of our ammonia are replaced by a carbon chain. You name these by substituting an amine. You actually have the name of the functional group in the name in place of the final E of the corresponding alkane. So we find these in vitamin B, hormones, anesthetics, like things that put you to sleep during surgery. So look at their amine, okay? Look at what they've done. They've counted the carbons, 1, 2, 3 carbons. So we would call that propane, right? If there were 3 carbons, they drop, because it's this NH group, they drop the E and add amine. And remember, the number is location, location, location. So that amine group is on the first carbon in the chain. So you may want to make a note here that you need a number to indicate what carbon the NH group is on. Okay. If we take organic acid and an amine and we put them together in the same molecule, we make an amino acid. And amino acids are the building blocks of proteins. Okay, so these are very important in our body. They contain both a organic acid, the COOH group, and an amine group. Okay, so you have both the C double bonded to O bonded to OH, you know, and again, that would be bonded to a C that is then bonded to an NH group, something like that. There can be lots of C's in between here. You know, there's whatever, 20 different amino acids that get together to make up all the proteins in your body. Okay, you don't have to know how to name amino acids. They have funny names. And then finally, amides. When you join amino acids together, you get a bond between the C and the N here. Okay, and that makes an amide group. So in the same molecule, and again, look at your table R here, right? The C double bonded to O is bonded to an N. And you get that. And again, this could be attached to whatever, right? Doesn't really matter, or just an H, okay? So you have your C double bonded to O right here, right? Bonded to N. Okay, and if you take a look at how they named their amide, again, they named it just like an alkane. If you count the carbons, there are 3, 1, 2, 3. So that's propane. But they dropped the E and added amide. And you don't need a number here because this group can only be on an end carbon. Okay, that's all it could be. If you put a number, that's fine, but it isn't necessary. Okay, so if we, yeah, I think that this one's a little more complicated. You'll never have to name that. I don't think you'll ever have to name any amides. All right. I think that's it for today. This next, when we talk about organic reactions, will be our last video. Have a good day, everybody, and we'll see you tomorrow.